what exactly it is and how it is different from machine learning approach, and how it is a part of security and data privacy. Then we are going to see the different types of FL models, workflow, topologies, and different algorithms that are used for federated learning. And thirdly, we are going to see a little bit of real world applications that actually make use of federated learning, and how things are changing in the real world application with the help of federated learning. Then we are going to summarize everything, and there's a small quiz for you to have the understanding what you have gone through in the session. You are able to, grasp it well or not. So we have a quiz at the end. So let's begin. Okay. So before we start with the actual definition of federated learning, I would like to tell you a story of a very old accountant who was uh, a little bit, advanced than other accountant, and wanted his family and friends to have a saving account where they can save money, right? So the scenario of the story is like, this accountant had a lot of family and friends, and that entire group of people, the accountant wanted, okay, I want to know that these people are having a lot of spending going on. So I just want to know what basically they are spending on, so that I can help them save money, right? So uh, if you have understood this problem, what an individual would do first, if you have X person you go to, and you will ask that person, okay, give me a bank statement or your spending statement, and I will go through that and I'll find the pattern, right? The person will come to me, ask me my bank statement and spending statement, and see, not everybody will be comfortable giving their spending statement or bank statement to this accountant, right? Okay, even though I know this accountant, I would not be very comfortable sharing my bank information with them, right? Even a lot of people don't share it with their family as well, right? So it's a very private information, and people are not comfortable sharing it with anyone. So that is an issue. That's the first issue. So what this accountant did was that whoever she wanted to help, what she did was she told them to write whatever they're spending, just write the number. If you're spending, suppose you're buying a mobile phone, okay, for 20,000 rupees, you just write 20,000. If you're buying clothing, you whatever is the spending amount of 5,000, you write 5,000 over there. So only the numbers, okay, you need not write more information, only numbers. She said, write only numbers. Now what is happening exactly over here is, if I see the bank statement, I hope everyone know what a bank statement is, right? Just give me yes or no in the chat. Yes, okay. So a bank statement has where you have spent the money, to how much you have spent, okay, what you have bought, okay, and how much money is remaining in your account, right? But what she said was, I want only the numbers, how much you have spent. So now this spent amount, okay, is something you can call it as a weight, okay, in the AI terms. I can, if I refer to it. So she's not getting all the other private information, she's only getting the information about the spending amount, okay. And later on, after a week or so, she can visit to all the people in her family and all the friends she has told to write down the numbers, okay. She can get the papers from them, and then she can find the patterns out of it, okay, how they're spending, okay, what is the pattern of spend that a person has done. So this entire story that I've just talked about right now, okay, is similar to how a federated learning works. So let's go to the next slide. Over here, if you can see, you have different devices over here, right? Different devices. We can call it edge devices. These devices are edge devices. Okay. and we can also call them as local devices as well. Now these devices that we have, okay, have a small or miniature AI models running on them. Now, these small miniature AI models that are running on them will be training, okay, according to the data that is fed to these devices. Okay, so if, for example, a phone, okay, has a miniature AI model, okay, installed on it, it will be running on the data that whatever I'm speaking, anything I'm doing on my phone, all those things will be the data to that AI model, and it will be training on that data. Okay, this is just a simple example. So it can be training on any data, okay, that is fed to that device, okay, or activity that is being done on that device. So these individual device will be training, okay, and after the training is done, there is a server, okay, you can see the server coordinating the training of global AI model. So all these edge devices or local device will upload their training models, okay. When I talked about the numbers that the accountant was getting, that is a training model, I can say, and they are uploading it to the server. Now this server will combine all the devices training model, okay, and create a global model, and this entire global model will be used for the further processing or predictions. Now, over here, if you know the concept of big data, okay, you do just give me chat. Do you know the concept of big data? How does big data works? Yes or no? I just want that. Okay, so just let me quickly explain you the concept, and then you'll be able to understand what the same concept is used by FL as well. So normally, what happens is that if I am doing a processing, for example, if I'm using Instagram, right? So if I'm using Instagram, I'm searching somebody, or I want to add somebody into, I want to follow somebody. Okay, so what I have to do is I have to search. The request is sent to the server will send the data to my device, right? And then I can find that person. Now, what happens is that request that I send to the server is processing the search. Okay, that is the name. Suppose XYZ person I want to follow, I search that person. So that data, okay, or that request is sent to the server. Server will take that request, try to apply the process to it, and search that person. Data is fetched, sent to me again. Okay, but when I talk about big data, it's the total opposite of that. The process is got to the data. Okay, the data never goes to the process. Server does the processing part, right? But here what happens is that you have the data somewhere, so you migrate the process to the data, and the data doesn't go anywhere, okay, leaving the place. So why it is important nowadays is because of the security purpose, because there is so much of you can say data is gold today, and if people have data, they are rich, okay, and they know how to use the data, they are rich, right? So if somebody steals your data, then there is a huge loss that happens. So you need to secure the data, and if you want to secure the data and you want to send the data, receive the data, you need to perform encryption, decryption, and a lot of security mechanism you need to implement. Now this increases the cost, okay, and we don't want to increase the cost. So what we do is we keep the data on the device itself, we just migrate the process. Okay, so this part is clear. I just want yes or no in the chat. Okay, great, great. So in federated learning, I'll just repeat the entire process. In federated learning, each individual local devices are uh, whatever questions you have, you can write it down and keep. Okay, later on, in the end, we can address that whatever questions you have. Okay, so let me fully complete with the session, then we can have that. Okay, someone has raised the hand. Okay, Professor Hassan, can we just keep collecting the questions if people have? and then later on I can address to the questions. Okay, so here each and every device will be performing machine learning. Okay, and after that the models that are created will be sent to the server. Okay, and this is just a basic architecture of federated learning. We are going to see how it is uh, also designed in a different way. Okay, so let's go to the next slide. Yeah, this is just for an information part where you can go through. The link is given in the source over here. Nowadays, like the Gen Zs are more into uh, cartoon strips or manga manhwas. So what I thought was that this is a very fun way to understand what federated learning is, and this is created by Google. Okay, federated dot with google.com. If you go to this particular website, okay, I'll just post the link in the website also. You can go and you can read the entire this comic strip, and you will understand what exactly is federated learning and how it is changing the scenario in the world. So it's a very what you can say, a creative way to make people understand about federated learning. So you can, yeah, go and read this article or cartoon strip. Importance of federated learning. Now, why was federated learning becoming so important nowadays? Like I said, that data is gold, right? And data cannot be, given to people who will misuse it. So it is important to safeguard it. Our privacy is very important, and we need not share data with everyone and anyone, right? So that's why federated learning has come into picture. So first, why it is important is because of privacy. Privacy plays a very important role over here. You don't want the data going to anybody and everybody. That's why we have privacy. Then we have data security. Now, when I talk about data security over here, the models that are created on the edge devices or the local devices, they are encrypted and then sent to the server. Okay, and then the server decrypts the model and aggregates it. Fine. So that's how the data security works in federated learning. When I talk about when I talk about, sorry, access to heterogeneous data, access to heterogeneous data means that, do you know what is heterogeneous data? Okay, so the heterogeneous data is that it's a mixture of different data. If I talk about heterogeneous data, it could be images, videos, it could be textual data, it could be semi-structured data, structured data. So all these kind of data are known as heterogeneous data. So when I talk about heterogeneous data in terms of federated learning, now, federated learning uses multiple devices to train their models, right? So, there could be a device that would be more of, having data that is related to images. Some could be more of video data. So, they are training on these kind of data, and there are different data available on different devices, and every device has been training. So, this is, the term access to heterogeneous data. Now, you might be thinking, if my phone is having a federated learning model, will it hinder the performance of my phone or my device or not? So basically, if we talk about this, the model that is fit into the operating system of your mobile phone, okay, it is a very miniature model, you can say, very low power consumption model, and it will not hinder the performance of your mobile application or device. Why? Because it will first check whether the model, okay, sorry, whether the device is active or not. Active means you're using it. If you're not using the device, that means that it is inactive, and whether it has access to the Wi-Fi or not. If it has access to the Wi-Fi, then what it will do is it will start training the model. Okay, it is inactive and has access to the Wi-Fi, then it will start using the data and start training. Okay, so that is how the performance is not hindered for your mobile phones or your devices or your laptops. Coming to the types of federated learning, now we have multiple types. Okay, basically, if you see the researches that are going on, there are a lot of different types coming up, but there are three basic types of federated learning. And the first one that I've already talked about is a centralized federated learning, where individual devices, okay, have their own federated models. They train and then they upload their training models onto the server, and then the server aggregates everything together. Now this is a centralized training. And if I talk about decentralized training, okay, now decentralized training happens where you don't have a server, and here you have individual devices. You can call it a peer type federated learning configuration as well, where you have different devices, okay, and each and every device is connected to the other device. And what happens is that whenever they train, okay, after the model is trained, what they do is they will send each other or resend each other the models. Okay, and this happens in a it is a continuous process, and it continuously keep happening. And these models keep on training based on the other models as well, right? So if suppose one of the device is training and the training gets completed, it will share the model with each and every system that is present in the decentralized network. And afterwards, it will also receive different models from other network devices as well. Now, what happens over here is, to this model, it will now aggregate all the models together, okay, and create a another model, okay, on which it is going to work further. So this is how a decentralized network works. Now, could anybody in the chat quickly give me what is the use of using a decentralized network over a centralized network? Okay, okay. People who don't know, a centralized network, there is a server, right? So if there is a server that is involved, it can be possible that there is congestion that can happen, bottleneck you can call it. And if there is a server failure, okay, then the entire network is down. Now, if you have another server uh, for a backup, it will take time to reinstate that particular server. So that's the problem in centralized. But in decentralized, even though one of the node is down, that would not happen. Okay. The third one is a heterogeneous federated learning model, okay, where if you can see, there are different heterogeneous devices, okay. The model that each and every device would use would be different, okay. Some device would be using uh, what you can say regression model, somebody would be using KNN model, some would be using a convolution neural network model, or different models would be using. So devices are different, okay. It could be a mobile phone, another device would be a sensor. So every device is different. So heterogeneous what you can say network of devices we have. and also there is heterogeneity in the models that are being used, and also the data that is being collected by them is heterogeneous. So in heterogeneous federated learning, this is a case where the device, the model, and the data that is being collected are heterogeneous, and each and every device is training on their own, aggregating the model and sending it further. Now, coming to the workflow and how it is different. Okay, so let's first see the federated learning aggregation server. Now, when I talk about aggregation server, uh, you can see the first part, A part over here. If you can see this over here. So first is a distributed global model. Okay, where what happens is you have a aggregation server and there are edge devices or the training nodes, we can say. Okay, it distributes the data over it and they are training on their own data. Fine. Then there is what happens here, training with local data. Now, whatever data they have of their own, okay, they are training on that, and also with the model that was distributed to the devices by the aggregation server. Now, after that, what happens is after they are trained, in the second step, they are trained. What happens is now the trained model is sent back to the aggregation server, and then the aggregation server is going to aggregate the local models and create a global model out of it. This is your aggregation server, how federated learning aggregation server works. When I talk about, and this is closely related to your centralized federated learning. When I talk about decentralized federated learning, I also talked about it is a peer to peer. So this is how actually the things work over here. First, any model, any system or any device in the network is going to synchronize the initial model with each other. Okay, so how many devices are connected? For example, if four devices are connected, all four are going to synchronize themselves in the same state as the other three devices in the network. Then they train on the local data and the local models. After that, see, exchange of the model happens over here in the third step. You can see where they are exchanging the models with each other, and all the network devices, okay, do the aggregation work. So this is how it happens, and if you can see, this is a continuous process. Okay, training the data and doing that is a continuous process. I'm sorry. Now, if you see the below part, okay, if you can see the below part over here, centralized data lake. Now, do you know what is centralized data lake or a data lake, guys? I just want to know in the chat whether you know what is a centralized data lake or a.
Yes, madam, I'm not audible to you. Madam, you can now unmute yourself.
Okay. Okay. So the data lake, we were on the data lake. Over here, this is how a non-federated learning model works. Okay. So here, if you see, there's a data lake, that the red or the pink part indicates the data lake, and all the all the data is getting pooled into the data lake. So whatever data we have goes into the data lake, and then in the second part you can see the cohorts or anybody who requires the data would pull out the data and use that data, and they will train on that data. So this is a non-federated learning model, or you can say a normal machine learning model works on this kind of concept. Okay, and this is uh, an insecure way, because if there is a very sensitive information that needs to be used for the training purpose, I cannot put it into, for example, defense information. Okay, I want some kind of prediction for the defense system. I cannot take the data, put it into the data pool or data lake, and train the model. I cannot do that because it's a very, very, very sensitive information. Okay, the health data. So the health data is also categorized as a very sensitive and very secretive information. So I cannot share it and put it into the data lake. So this kind of model cannot be used for the sensitive information. Only if when you require it to train on the public data, then it can be used. But when you have information, or you want to create applications that is uh, uh, you know requiring data privacy and sensitivity of data is there, then you will use federated learning models. Coming to the federated learning topologies. So the topologies, basically, you might have studied topologies in computer network. You have different kind of topologies. Mostly the federated learning that topology that it uses are centralized, decentralized, hierarchical, and hybrid hierarchical. Okay, so when I talk about centralized topology, here you can say that it is connected to one node, but here again the problem is that important node fails. Okay, then the entire topology gets disrupted. In decentralized topology, it can be like every node is connected to every other node in the network. Okay, so every n node in the network, there will be n minus 1 into n connections. Hierarchical, in hierarchical, every, if you see the edges, okay, the bottom nodes, these nodes are connected to one server node, and these server nodes again are in terms connected with some other higher nodes. Okay, that is a super server node. So this is a hierarchical connection. When I talk about hybrid, you might see that hierarchical and hybrid look almost what it looks same, but in hybrid hierarchical, what happens is that it makes use of centralized as well as decentralized network. So over here, if you can see, the yellow part indicates that it is a centralized network, and the green part indicates it's a decentralized. So it is a combination of centralized and decentralized connected in the hierarchy format. So that is your four topologies. Then coming to the FL compute plan part, uh, these are the topologies that basically work based on the computation that happens. Okay, and how the aggregation of the information works. So if I now talk about the sequential one, what happens is that the first, if I take the topmost node will train and provide the model to the second node. Okay, the node below it, then it will train and it will share the model with the node below it, and so on. It happens in the sequential order, and the last one will send the model to the topmost one. Okay, so this is how it keeps on happening. So that's why it is known as a sequential model. When I talk about aggregation server, what happens? It is the same, where all the nodes send it to one node, and it aggregates and send it to send the aggregated model back to all the nodes present. When I talk about peer to peer, all of them are doing the aggregation on their own. Okay, coming to the very important part, I have been talking about aggregation for a long period of time, but I have not yet explained what aggregation is, right? So there are few models or few algorithms, you can say, that are used for aggregation purpose. If we talk about aggregation, what do you mean by aggregation is that we have, like for example, few things here and there randomly, we put them together is aggregation, right? So here in federated learning, if I am using multiple devices to train, so if I want to make a global model out of it, I have to aggregate, right? So there are three different algorithms over here. First is stochastic gradient descent. Second is federated averaging. Third is basically a dynamic regularization model algorithm. So here, when I talk about the first one, okay, stochastic gradient descent, let me explain you with an example over here. Let's say that there is a playground that is to be designed in your neighborhood. So what happens is that whoever is having the authority to actually construct the playground, what that person would do is they will go with the paper and pen to every household, ठीक है? And they will give that pen and paper to every person and tell them that how would that playground would be, okay, design input. They want design input for that playground, and every house in the neighborhood will write down, okay, what first thing come to their mind, okay. The first thing that comes to their mind, they will write down on the paper, okay, the playground should have, a basketball court, a playground should have a gym area or something like that, okay, for a children section. So whatever comes to their mind, they would write that, and they will give it back to the person who has come to ask for the suggestion, right? So when this you see the scenario, what happened is that there is a person, okay, that person can be the server, okay. The server will ask for the model, and they will, when the raw gradient will be sent back to the server, okay. Not thoughtfully trained model would be sent, a raw gradient model would be sent to the server. So this is a federated stochastic gradient descent, okay, model, and an example for that, so you'll remember. Then federated averaging, okay. In federated averaging, what happens is that whichever model are trained, they are sent back to the server, and it is aggregated by averaging method, okay. So now for this, what I can do is I can give an example of like uh, in your school or college, okay, you have a group of students, okay, who are working on some assignment, okay. So now all of you are working on the assignment. Now what can happen is that a person will work and write a rough draft, okay, and then re-evaluate that draft and will come up with a final draft. So what happened over here is that first draft that was created for the assignment, for the group assignment, okay, now whatever section that a person was doing, that a person wrote a rough draft and then rewrote it, okay, and finalizing it. So now it was a rewritten and thoughtfully rewritten thing, okay. So वैसे ही होता है in your federated averaging. What happens is that a model is trained, okay, but it is retrained for a better purpose, okay, better impact, you can say. So that is a federated averaging model. When I talk about federated federated learning with dynamic regulations is, let me again take an example for this. Let's say during exams, okay, five of the friends are sitting to study, okay, and all of them are studying the same topics, okay. So what happens is that everybody is sitting together, okay, and studying all the same topics. Now what happens is that everybody will take x amount of time. Now if I reassign, okay, and I say that five students are sitting and learning something for the examination, but suppose one of them is very good in topic A, second one can do topic B, third one can do topic C, fourth one can do topic D, and fifth one can do topic E, right? So now what can happen is in 1 hour they can finish their own topic, okay, and then in the rest of an hour, what can they do is they can explain the others, okay, with what they have learned, and everybody will take, uh, like less amount of time to study all the five topics, okay, and within 2 hours or 2.5 hours everything is done. So your dynamic regularization works on this particular concept only, that whichever device has suppose images, okay, so it will work on those images based on object identification, and it will train the model according to that. If some other device has suppose textual information, and it would be working on clustering algorithm or something like that, right? So here what we are doing is we are dynamically assigning and regularization of devices according to the data that is coming and according to the environment they are present in. Coming to the real world application, uh, now if we talk about the real world application, uh, what just I'm giving you 2 minutes of time, just think what could be the application of federated learning. What you would you think could be the application of FL? Okay, so if I move ahead, okay, so how many of you have thought of these application or something related to these applications? Now if you see these use cases, okay, over here I've provided some percentage as well. Now when I talk about healthcare, okay, when I talk about healthcare, uh, 83% of the applications that are built on healthcare system are using federated learning. When I talk about finance, 78% of the applications that develop for financial purpose, they are using federated learning. And even smart cities, they are using federated learning, but it is still lesser. But it is said that in near future 2030, it will be 100%. Okay, all the devices would be using federated learning for updating and for different case studies. We are going to see all those case study one by one. Let's go to healthcare case study first. Now, when I talk about healthcare, what comes to your mind? Disease prediction, okay, personalized medical, recommendations, or it could be drug discovery or something like that. So when I talk about this, there is one case study, very famous case study that exists. That is your Google on device personalization. Okay, the Google on device personalization says that your health data, your activity data is tracked by Google, right? Using your Android phone. Now that data can be used for your personal health assistance, okay, using federated learning model. So your health data based on your mobile phone activity, what is your sleeping pattern, and how much active you are throughout the day, how much of steps you are taking throughout the day, how much stair climbing you are doing, how much if you have a watch that is synced with that, okay, smartwatch that is synced with your device, it would give you other vitals as well, like heartbeats, your oxygen level, etc., etc. So all these things are data that is taken by Google on device personalization, for on device personalization, and they try to do the disease predictions with this data. Even drug discoveries can be done using these kind of data, as well as using your information, uh, and if you have some recent test done and you're storing that information in your mobile phones, that can also be used for prescribing drugs to you. So that is also a very wide field of study that is going on right now. And the disease prediction and discovery, these two are like in their what you can say booming phase. But prescribing medicine, they're still working on that, because we cannot prescribe any medicine and every medicine to anybody, right? Because some people might be allergic to something. So this is a little more into a research, what you can say, phase right now. Then coming to the second part, just a second. Okay, second part, that is your finance data. Now, when I talk about finance, uh, there are so many frauds you might have heard of. Okay, so fraud detection is one of the major aspects of federated learning research, where and actually a lot of companies are coming together. See, what happens is when a fraud happens, what the fraudster does is that they would first fool one institution, then go to another institution, pool them. So now these different institutions, what they're doing is they act as individual, what you can say, federated learning nodes, training nodes. They train the model, and all these nodes data are aggregated, and then their models are updated. So now, even though there are three institutions altogether, for example, then all three of them will be knowing that this is a fraudster. Okay, although the fraud did not happen in their institute, they would be knowing about it because of the federated learning model they are using. So that is one of the major research areas, and the case study of finance domain. The credit card scoring as well, okay, because sometimes there are scoring frauds as well that happen, credit card scoring fraud. So here also federated learning is used to calculate the score of a person in one. What happens is, see, credit card that is given to you in India, okay, the scoring would be different. A person might do a fraud over here, go back to, suppose, the UK, and they will take another credit card over there, do the fraud, go to some other country. So even if the countries use the federated learning model and calculate the credit scoring, then nobody can fool any country like that. So that is another model for that. Coming to the third, that is smart cities. Now you might have heard about autonomous cars, IoT systems, right? So all these are coming together for your smart cities. The dash cameras or dashboard cameras, the traffic cameras and the road cameras, all these are coming together for what you can say, helping understanding what is the pollution level, what is the congestion level of a particular road. If there is to be, like, the metros are coming nowadays, right? Metro routes from one place to the other. So how the planning department would plan route. Okay, that also can be done using your federated learning models. Okay, help of the federated learning models for the smart cities. So these are the few use cases that we have seen. Coming to the summary, the what we have studied first, the federated learning model is a decentralized learning model where different individual devices learn on themselves, and you can have a type where you can centralize the aggregated or decentralize the aggregated. Then it is a collaborative learning model where we have seen that multiple heterogeneous systems and networks can come together and work together. One example we saw in the financial domain, where different institutes are not working individually, but they're collaborating together to find the credit card score fraud and different other frauds in the finance domain. Even in hospital, we can use this. different hospitals can aggregate the information. So, in order to understand the disease prediction models as well, right? We also focus on privacy and then efficiency and scalability of the system. And lastly, we saw how the diverse the applications of federated learning models are. So here we complete the session. I have a quiz planned for you guys. If you can see this QR code, guys, you can scan it and join the quiz, and then we can have a really quick quiz. It's not a very big quiz; it's a very fun quiz. You can just go through it. So just scan this code so we can have a quiz. Are you able to see this? Okay, quickly join in, guys, so that I can start with the quiz. If you want, I can share the link of the quiz in the chat. If you enable the chat for me, I could just share the link if you want. We'll wait for 2 more minutes and then we'll start the quiz. Okay, so we're going to start with the quiz, guys. Let's start. They can answer that. Okay, so here we conclude. And if you have any doubts or queries, you can email me. I'll just put out my email address somewhere over here so that you can take it and contact me if you want. Okay, so this is my email address. You can make note of it. And if you want to contact me, you can contact it on this email address. Now we can conclude and stop. I'll stop sharing my screen. So if you have any questions over here, you can ask me straight away. Or if you have given the questions on your uh, YouTube comment section, then Professor Hassan, could we have a few questions that I can answer?
Uh, yeah, well, thank you so much. We now have a formal thank you session for which I will now call upon Professor Kamlesh Pal from Computer Science Department to please give the vote of thanks.
Good afternoon to everyone. I, Professor Kamlesh, on behalf of Computer Science Department, heartily thank you, our respected founder, sir, Professor Asgar E. Lakdawala, sir, our dynamic principal, ma'am, Kalpana Patankar Jain, managing trustees, Anna ma'am, Malika ma'am, and Akila miss, our vice principal, Dr. Chitralekha ma'am, and Sanchita ma'am, and head of the Department of Computer Science, Professor Ritika ma'am, and all the teachers. We have just witnessed an exceptional presentation on fascinating subject of artificial intelligence. And it is my honor to extend our heartfelt thank you to our resource person, Ms. Alam Ansari. Ms. Alam Ansari, your presentation on federated learning on advancement in AI has been both enlightening and inspiring. The depth of your knowledge and the clarity with which you explain the complex concept have truly brought the world of AI to the life for all of us. We deeply appreciate the time and efforts you took to prepare for this session and share your valuable knowledge with us. Your insight not only shed light on the current advancement in AI, but also ignited a spark of curiosity and enthusiasm among our students. Your passion and expertise have left a lasting impression, and we hope you all for the inspired as I do the explore and engage with this exciting field. We would also like to thank all the coordinators of the different colleges, teachers, faculty members, and student volunteers for sharing our messages on the social media platform, because of which we are able to achieve this large amount of participants. We are overwhelmed to have this 855 number of participants registered for our today's webinar. And last but not the least, of course, we would like to thank our dear participants who have given the precious time and were very attentive in listening this session and making it a grand success. The success of today's event, of course, lies because of our student, our participant. Thank you very much, everyone. Feedback form link is going to be shared in the chat box. Link is going to be active only for an hour. E-certificate will be given to all the participant who has registered plus who has attended the webinar, and they will fill the feedback form. And the feedback form link we are going to share in chat box only. You will get certificate or you will receive certificate within 2 to 3 working days. Thank you, everyone. Thank you once again. Thank you, ma'am.
Thank you, Professor Kamlesh Pal, for giving the formal vote of thanks. I once again thank Professor Elam Ansari for your precious time. Thank you, madam. Thank you, all the student participants. Once again, I repeat the same instructions that participants will only receive the certificates if they have attempted the quiz, if they have attended the session, if they have done the registration successfully. Otherwise, those participants will not be receiving their certificates. Please make a note. The link is already shared in the Zoom chat box as well as on YouTube. Link will not be shared on WhatsApp group. Also, please make sure that when you fill the feedback form, you put in your correct details, because no more changes and modifications will be accepted in the certificate, or any kind of corrections will not be tolerated at all. Thank you so much for joining us.
Link will be active.
Link will be active only for 1 hour. On behalf of Royal College of Arts, Science and Commerce, Autonomous College, we extend a formal thanks to everyone. Thank you.